Let's get another example of making a Maclauren series. First, we're going to need the derivatives. Oh, boy. So we go and we find all the derivatives of e to the 2x. That's 2e to the 2x. That's 4e to the 2x, but I'm going to write it as 2 to the 2. That's 2 to the third because I'm using my chain rule on my e to the 2x. It's spitting out an additional 2 forever. Now, I'm going to go and I'm going to evaluate all of those at 0 because this is a max series. And that's what it is. It's a Taylor series evaluated at 0. So we go and we throw our O in there. Notice what's happening to that e. E to the 0 is 1 all day, every day. So that's why I'm getting these guys. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. Then I take those evaluated derivatives. And I'm going to write out a couple of terms, because I'm trying to find the sequence. Yeah. I'm trying to find the sequence that governs this Maclauren series, and the series is in that form. That's why I'm going to take those derivatives that are evaluated at 0, divide them by n factorial, and multiply them by x to the n. So that's 2 to the 0, and then 2 to the 1, and then 2 to the 2, and then 2 to the 3, But then what? I'm trying to find a pattern, and I think I found one. There it is. That's 2 to the n, x to the n, divided by n factorial. And hey, guess what? That converges everywhere. But that's another video. You know what? Maybe I'll include it right here. How do we find the radius of convergence? We're going to use the ratio test. The ratio test. That's the limit of an plus 1 divided by an. Then we're going to do some algebra. That needs to be smaller than 1 if it's going to converge. So let's evaluate that thing on the left-hand side. Dividing by a fraction is the same as multiplying by the reciprocal. So we reciprocate, and we really give back to this problem. That's how I got the n factorial divided by the 2 to the n, x to the n. Now, a whole bunch of stuff is going to cancel out. We're using the ratio test. Boom, 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 boom. Oh! And then left on the top, I have 2x divided by n plus 1. And I pull that n plus 1 out because it's always positive. I don't need to worry about that. I'm talking about positive n's. Yeah. So in the end, when we run that limit, we get 0 times that. And now the question is, when is 0 smaller than 1? Oh, everywhere. And that's why this converges everywhere.